Hi everyone. In this video, we will see merge two sorted lists problem. So in this problem, you are given the heads of two sorted linked lists, list 1 and list 2, and you have to merge this two lists into one sorted list. Remember here you are given the given link, both of the given linked lists are already in sorted order. Also, one thing that you have to keep in mind is you have to splice together the nodes of these two lists. So you are not allowed to create separate nodes or new nodes for the resultant list. So you just have to manipulate the pointers of these two lists. And as a result, you have to return head of the merged linked list. So for example, there is the list one of with nodes 1 to 4, and let's say there is the list 2 with the nodes 1 3 4. As we have to merge this list and maintain the sorted order, the output or the resultant linked list will be 1 1 2 3 4 4. So if we take a look at the strategy that we can apply here, first what we have to decide is where to start. Whether to start from first node of linked list L1, or whether to start from head of linked list L2. So we can directly compare the nodes L1 and L2. Currently they are pointing at the head location of respective linked list. As both of these are already in sorted order, so we can compare these head nodes, and if L1's node is less than or equal to the value at L2, we can mark our resultant linked list head node as L1. Otherwise we will mark it as L2. So currently we can mark this as a result pointing to L1, and after that we will move this L1 by one position. So now L1 starts pointing at here. Now what we have to do is again compare the nodes at L1 and L2, and basically we will keep doing this unless and until one of these linked list reach till null. So now when we compare L1 and L2, now L2 is less than L1. So what we have to do is results next, it should now point to L2. So what we have to do here is remove this linking between this 1 and 2. We have to remove that, and we have to link these together. And after that we have to move our result node, we have to move our L2 node now. So now L2 will come here. Again we compare L1 and L2. Now as L1 is less than L2, again we have to shift this pointer from 1 to 3. We have to delete this, and we have to create a pointer for a next node from this 1 to this 2. So basically we delete this, and we join from here to here, and we keep doing this until we reach till the end. So after this we increment our L1. Again compare 4 and 3. As 3 is less, we delete this pointer and create a new pointer from here to here, and shift our L2 to here. And as again we compare 4 and 4, as 4 is less than or equal to, so we can delete this pointer and create the pointer from this 3 to this 4. Now once we reach till this point, we increment our L1. Now L1 becomes null, right? So in this case, what we do here is whatever remaining things are there from our L2, we have to append this as next pointer. So that's it. So we just make the next node from this 4 to L2, and so maybe there are like many other nodes in this L2. We just don't care about that. We just set next node from this 4 to this L2 and just return our result. And same thing you have to do. So if we reach till null for L2 first, in that case you just have to append L1 as next node for this 4 and return the result. So if we take a look at source code, we have given this merge to list function where we get L1 and L2 reference of head pointers of both of this linked list as argument. And first these are like just edge cases, like when the L1 is null, we just return L2. If L2 is null, we just return L1. Now as we saw earlier, we initialize our result node, and when we first check the whether L1 is less than L2, and if that is the case, we assign the result to L1 and move L1 to L1's next. So this block is just the condition to initialize our result node. After that, while either L1 or L2 reaches till the end, we go on doing the same thing. So we just compare L1 and L2. Whatever is the less, as we want the both of these link list to be in sorted order. I mean the resultant link list to be in sorted order. So we just compare these two nodes. Whatever is the less, whatever has the less value, we just keep appending it to the resultant list and increment that respective pointer to its next. So for example, if L1's value is less than L2's value, we will assign temp.next to L1 and we will increment L1 pointer. Otherwise, we will assign L2 to temp's next and we will increment L2 pointer. And after that, we again increment the temp pointer. Once this while loop ends, that means either we have reached till the end for L1 or we have reached till the end for L2. So here we just have to check if we have reached till the end of L2, that will mean that L1 is not equal to null. So when L1 is not equal to null, that means L2 is equal to null, and in that case we have to just assign temps next to L1. And second condition is when L2 is not equal to null. So that was the case here. So L1 reached till the end and L2 was still pointing to 4. So in that case, we have to just assign the temps next to L2. So this started pointing to L2. And whatever nodes are there after this L2, that list will remain as it is. And after that we have to return our result pointer, which currently points to the head of our resultant linked list. So this list now will become this like 1 2 2 3 4 and 4 and then null. As we are traversing every pointer of this both of these linked lists, the overall time complexity will be O of n plus m, where n is the length of your linked list 1 and m is the length of your linked list 2.